Let's start with the Meander Dashboard. This is the primary interface to Mender where you can view your fleet at a glance. You can see summary information about your devices as well as about any ongoing deployments. Moving over to the Devices tab, you can see that I have one device in my fleet. It's an Intel Core i7-64 device running the Release 1 node radio code. My setup here is an up-squared board with an LCD panel attached over HDMI. I'm running automotive grade Linux. Note the icon count on this front screen. Note specifically that there is no radio icon. Let's take another look at the device details in the Mender web user interface. From here you can see things such as the device identity, which out of the box is composed of the MAC address, as well as the device inventory, which is a set of key value pairs. Both sets of information can be updated by you based on the needs of your particular device. On the Releases tab, you can see information about all the versions of software that are available to install on your devices. In this case, we have two versions, one with and one without the radio. Opening up the release details, you can see what kind of image, what kind of artifact that you have. In this case, it's a full root file system image update. Drilling down a bit more, you can see some details such as the original file name, the checksum, file size, and other similar generic information. Now let's take a look at the Deployments tab. This is where all over-the-air updates are triggered to your device fleet. Once you create a deployment, you need to select a target release. In this case, we'll select the one with the radio image, and then you select a group of devices to issue the deployment to. In this case, since we only have one device, I'll simply select all devices. Take note of the device type listed here. In the case where you have multiple device types in your fleet, there is a type check done to ensure that you are installing the proper image on the devices to avoid corruption. Now just click Create the Deployment to start the update process. Once the deployment has started, we can check the status. We see here that it is in progress. If we click on the deployment in the list, we can see more details. This tells us that the device is already downloading the image. Now, in this particular case, I'm actually going to simulate a failed deployment by pulling the power as soon as it starts to reboot. This should demonstrate the rollback capability of Mender. While this update installs, let's jump over to the Mender documentation site. In our Getting Started section, there are instructions if you want to download and set up this environment on your local system. We provide a Docker Compose file with all the details and components needed to actually run a Mender demo server on any system that is capable of running Docker containers. Out of the box, this environment will include an emulated device. There are images that you can download and deploy to this device to start getting a feel for the Mender workflow. To build a Yocto image for the Up-Square board containing Mender, go to our Mender Hub site. This is our community site for device integrations. This page you're seeing here will walk you through setting up a full Yocto build environment on the Sumo branch. All the instructions here will get your build up and running and walk you through the initial provisioning of the device with the produced images. If you want to replicate the automotive grade Linux setup, there is also a discussion page on the Mender Hub site that will walk you through this. These instructions are very similar to the previous ones, except that there are a few additional repositories that are needed to be included in your build. Now we see our board has started the reboot after the installation is completed. Once it comes up, gets through the bootloader, and starts running the kernel, I'll pull the power to simulate a failed update. Now the Mender logic in the bootloader detected the failed update and has successfully rolled it back to the previous known good configuration. When this system finishes booting up, we'll see the display without the radio icon in the list. Back over in the Deployment Process tab, we see that the deployment has completed with a failure. You can download and view the logs from this screen. In this case, it won't tell us much since it was simply an external power cycling issue. Now we'll go ahead and recreate the same deployment that we just tried. This time we'll let it run to completion so that we can see the addition of the new feature into the target image. The deployment is created in the pending state. On the next check-in on the polling interval from the client, the client will start the download and we'll see the deployment move from the pending to the in-progress state. After the OTA install is completed, the device reboots, and now we see it coming back up again. And as expected, we now have 9 icons on the home screen, including the newly added radio icon.